Welcome everyone to Nerves of Steel by Jon Carstens. The benefit of a remote webinar is that I don't have to stand in front of a crowd. It's super convenient for an introvert, but for those of you who must see their speaker, here's a picture of me. Great. Now that that's out of the way, we can get started. First, to clarify, I'm not talking about a piece of steel that we try to slam nerves onto and somehow make it smart, but rather practices for hardening your Nerves device setup so it's really hard for a rogue update to turn it into a brick. But first, let's overview some anatomy of a Nerves project. This is your cool little SD card. You just got a pack of 16 in the mail because these Nerves devices are going to be everywhere, all over your house. Windows, doors, doesn't even matter. When you create a firmware and burn it onto a device, it creates a few different pieces on the SD card and partitions for different purposes. First, there will be a small bit that's the U-boot environment, simple data storage to help prepare this helps prepare the system for boot and some small variable storage. Then we'll have the boot partition, just essentially the bits needed to start the boot process, get things rolling. And then the root file system, or commonly referred to as rootfs. This is the Linux nuts and bolts needed to actually run. And just as a note, the boot and the rootfs partitions are essentially what makes up a quote-unquote firmware. And lastly, we have the application partition. This is the only writable partition and is where you would put application-specific data that you might need to be persisted across boots. And because of that, it's typically expanded to fill the remaining space of the drive. Nerves also takes the setup further with an A-B partitioning scheme. What this means is that the boot and rootfs partitions are essentially split into two, an A firmware and a B firmware. And only one of these is active at a time. So the next update will overwrite the other non-running partition, leaving the previous setup intact, which is super great because sometimes you might update and only discover after boots that you have a bad gen server message in the wild. And then that's when all the finger pointing begins. Things can get hairy, but fret not. Because of the A-B partitioning setup, you can call nerves runtime.revert, which will mark the previous firmware to be used and reboot the device to it. And that safety net feels kind of good. Oof, save ya. But that requires that you actually get to runtime and that your application is mostly running. So what about the other times when you're on fire, coding like a maniac, and it's just flowing from your mind to your fingers into pure bliss? You get this up. It's perfect. Things couldn't be any better. Nay, genius. So deploy it. Don't even need to test it. Sheer confidence. And something is failing to boot. Well, BeagleBone systems that we support in Nerves can actually help with this. Their boot process allows for adding scripts into a U-boot environment that can be run before booting and mounting the rootfs. So we're able to read some U-boot and variables and do some simple assertion checks to know if the last firmware booted successfully. And if not, that firmware was bad and we should revert. Now, this is fine and dandy, but you may be wondering, what about Raspberry Pi systems? Well, unfortunately, they do not support this U-boot scripting magic in the boot process. But don't worry, there's hope. Bring in init ramfs. What is that, you say? Well, here's how it works. You have your typical U-boot environment on disk, and we can have cool fancy scripts, but we can load a very minimal root file system in memory before mounting the real root file system. The minimal root file system we mount is called nerves init ramfs, and In Nerves init RAMFS, we can run some very simple scripting to do the same checks, and if the check fails, we revert. Really similar practices here. Pretty cool, if you ask me. In fact, so cool and new in these Raspberry Pi systems that this is the pre-release version 2.0 of Raspberry Pi, Nerves official systems. But this is still very much a work in progress and is currently only published as release candidates. You can check out the code in the v2.0 branches of the RPI systems and also read more in the Elixir forum post from these links. Now, let's talk just a minute on this simple revert logic that's in the BeagleBone and the soon-to-be formally released Raspberry Pi systems. So say you're a firmware and you're starting up and you ask, have I booted before? Well, if it's no, great, boot it. Let's get this party rolling. You gotta at least try to boot once, otherwise you'll never get anywhere. But what if I have booted before? Well, was I validated? And if yes, great, boom. Keep on keeping on, man. Boot it up all the way. But if no, then I booted once, something must have failed, and this is now a subsequent boot, so I should definitely revert. And for context, these questions that are asked in these simple scripts are just U-boot environment variables that get written in various times and are being checked. Specifically, nerves_fw_booted for the boot check, and nerves_fw_validated to tell if I was actually a good firmware or not. So what about the case from earlier? When the device starts up, but your application has an unforeseen blunder. Well, that U-boot variable, nerves_fw_validated, is there for you to manage at runtime. In fact, because the question, quote unquote, what makes a firmware valid, differs so drastically case to case, Nerves makes no assumption here, and you're required to set it when the firmware is valid enough for you. If it is not set, then the next reboot will cause a revert. There are a few ways in order to set this. If you're running Nerves runtime 0.11.2 or greater, then you have this fun little function, validate firmware. It can be called anywhere you need in your code. Or you can also just write the U-boot variable directly through some helper functions, or if you have direct access to U-boot and want to write it and manage that, you can do that too. Now sometimes there isn't a lot of logic for when to validate a firmware, and just getting to your application is good enough. This could be an absolutely valid call in using these systems. And other times, you might want to check other things to consider firmware good, such as internet connectivity, or maybe your connection to Nerves Hub has to be strong and working, or your connection to other types of services or devices or sensors or whatever it be. And in fact, you can take this one step forward and tie it into the Erlang heart module, which in Nerves is tied to the hardware watchdog. And if you're interested, this is talked about in more detail in You Gotta Have Heart, an article written by Doug Self on the Embedded Elixir forum. I don't know if that's a forum. The Embedded Elixir blog, whatever we call it. Anyway, there's a link. It's got some great details and examples of how you use it. But the TLDR is this. You set a module and a function for Heart to call back to. Then Heart will make calls to this callback, and this happens every few seconds. And if it returns anything besides OK, Atom, then the whole thing reboots. And if this is the first time you booted this firmware, then things will revert. And that's because any heart check failure triggers the watchdog to force the system reboot. But if this is already valid firmware, then it's basically just taking the IT approach for you and may avoid one of these types of calls. Now let's shift gears a second and talk about startup. Let's say I have an awesome Elixir application with some dependencies. Before my application starts, each dependency has to be started and successful. And if they all succeed, then great, my application now starts. And then I might even do a little happy dance of excitement because cool. But what if my application dependency started fine, but my app fails to start through another blunder? Well, now they all fail, which means suddenly you're missing pretty crucial pieces on your hardware like networking or remote access, maybe SSH, or even the ability to update the firmware and get past these issues, such as through Nerves Hub or whatever firmware update service you might use. And that's just slightly disheartening. So another tool to use with your Nerves devices is shoehorn. Many of you may have seen this and maybe not understood why a lot of us will say, put this application in shoehorn. But essentially, you would configure a list of applications you expect shoehorn to handle in the config.exs. And what this does is separate those applications' startup process from your app. So shoehorn will take these such applications, start them outside of your application's sequence, but still guaranteeing that they'll be started before your application. And then the dependencies start like normal. But if your application crashes and burns on startup, now those separated applications are still running. And with these particular dependencies still running, that leaves you with networking, SSH, remote access, and still your connection for a firmware update. So put that in your tool belt towards hardware invincibility. There are definitely more ways that you can have nerves of steel. And if you have more ideas of how to harden your device setup to prevent a brick, then I'd love to hear about it. And if you can only take one thing away from this talk, it would be the mantra, always be able to update the device! Exclamation point. If that is the driving thought, then you'll surely be thinking about your hardware very differently and you'll be A-OK. The end. Thanks. Quick shout out. Thanks to SmartRent for supporting me in my crazy hardware adventures. It's been wonderful. You can reach me at these places if you so desire. Spoiler alert, I'm not very exciting. And if you have fun talking hardware, come geek out with us once a month at the Nerves meetup and find more information and dates and times at nerves.group. Now some obligatory links to images to like the site where I get the cool things. And thanks for watching. Happy hacking.
I think we have a bit more today. No. So, John, are you there? Hello.
Yes, I am.
That would leave us with 25 minutes of questions, I think, if I can do my time zone calculation right.
Yes.
Oh, sorry, I just destroyed a spreadsheet. No worries. So if people will put their questions in the Hoover app. Currently, there are no Oh, I got away from the page. There's a steel there. Yep. So does anyone have a question in the chat? You can unmute yourself and ask. No one? Then it's up to me to find a question.
Hey,
so
one just popped up.
Awesome.
Can other platforms like NXP, LPC range easily be added? That is a great question. It kind of just depends. The only requirement is really that you're able to run Linux on your processor. And should you be able to do that on the hardware, you would be able to then run Nerves and some of these ideas on it. NXP, LPC, I'm not 100% familiar with.
It's all news to me.
It's an ARM Cortex M. Potentially. This particular one would just take some investigation. So I guess I don't have like a real hard answer for that.
I don't know if he's placing. I see him in the room. If he has a solution to that kind of board or chip. No, you're usually so talkative, Pierre. So let's look at the questions again. No. So if I'm an aspiring hardware hacker, how do I get started with all this stuff?
I think, well, first you need the hardware. You need to pick something. I think it all just starts with hardware and an idea, and then it's pretty easy. There's a Nerves hex archive package where you can get a mixed nerves.new style command task to generate a brand new project, and that project will, I don't know, will fill in a lot of the nuts and bolts to get you started in the beginning, and that makes it easy to build a firmware, burn it to a device, and just get at least something up and blinking or doing something simple. And then from there, you can customize, take deeper dives, do things of that sort.
Has there been written any books about nerves?
There has not been any books written about nerves.
I
think there's a desire to do so, but there's also the desire to find time to do so.
I guess that's the big one. Time. So let's see. I'm like I have developed Tortoise, but I don't really have any like come to mind with any hardware hacking questions right now. It's also very late in the day, so if anyone from the audience can help me out here with your, does anyone in the audience have any hardware projects that you want to talk about using Nerves or? I miss being able to see people. So if you can help out by turning on your cameras. Oops, ask a question. Nope, no more questions. Yeah, Jon has unmuted people, so if you want to chime in, you can unmute your mic.
Hi guys, one question. I think I tried it some time ago, like on a Raspberry Pi, but it started getting hot, and I don't know why. So I probably have to read the documentation to to start seeing how I can like connect the serial cable, because I'm probably a bit more like Martin Gausby. We've got people which are experts in these type of systems, and I'm normally just playing around. So if you're debugging, serial port is probably the best for these type of systems.
Yeah, I mean, if you're comfortable, if you're familiar with that, then yeah, that's usually generally easy. Most of the systems by default leave the serial port on some of the GPIO pins available so that you can do things like this so there's no extra minimal setup to get that working. And then yes, then you don't have to deal with an extra screen or messing up your network connection or anything like that. And it's a totally valid way to work with and debug and manage.
Okay, thanks.
A question has come in on Wahoo. So there wasn't.
Okay, let me look at that.
Yeah, I don't know if Harvard want to ask it himself. Where are you? There. Well, I'll read it then. There was an interesting talk about something called BEAM ASM earlier. Would native code compilation make supporting other devices easier? I think it was only for, right now it was only for x86 processes though.
So I missed this one. I've just been catching up on some of the excitement from Twitter and other forum places about it. I think what it would make easier, not necessarily for the way that Nerves tooling works and building the firmware and putting it on the device, but I think it would make things a lot easier for how to get extra tools or components on a Nerves device. Like, for example, if you're going to do sort of more custom work, like you want to do more video processing or more graphical processing, and these require other compiled libraries or packages, which we don't include by default in the Nerve system. It can be kind of a process, and either like trying to make sure you can cross compile that stuff and create a binary and use it on a device, or even you essentially create what we call a custom system, where you take the existing official Nerve system as a base, and then you clone it and make all the changes you need to build root and other pieces to get the certain other packages you need outside and extra. And some of those can get cumbersome, I think, to develop and maintain. So what I am most interested in with, like you're saying, is being able to use it for the applications and other native compilation in relation to using application or using libraries and packages on your device without that extra work and requirement of learning a lot of the deep internals of Nerves and customizing systems and that sort. So I guess we'll see, but I also really need to go back and watch that and figure out what all we're talking about here.
Just looking at the Hoover. So what is, if I build a device that only operates from a cell, what is the smallest device I can put Nerves on that can be run from a battery?
Oh.
And how long would it be able to run? Say I take a temperature measurement every 5 seconds or something like that.
That's a great question.
Thank you. I just made it up.
he just made it up. I don't know. So one of the smallest devices that you can get easily without creating your own custom board and trying to make your own use of a board with a tiny processor and control the power. The Pocket Beagle might be a good choice. It's a really small I mean, it's like this big. It's a really small board. Yeah, sorry, like that means nothing.
Banana for
It's like
scale.
half an AirPod, half the AirPod size. But anyway, it's a small form factor. I don't know how much power draw it's going to use though on a battery to accurately answer if it's going to be a valid use case for battery pattern and taking measurements. It's really just all going to come down to like really fine tuning your system. You get something up and then you start measuring your power draws and start looking at how to reduce that in your measurements. But that would definitely be a really small and easy form factor. There's also, so Nerves doesn't run on some of the much smaller, lower power microprocessors that really give you this battery nice setup. But there are ways that you could communicate with them. So say you had a base controller you ran with Nerves to manage everything, and then you use little, I don't know, like little ESP devices or something that can Arduino style, really low power, can go into deep sleep, that are external and just communicate back either via radio or a Wi-Fi 2.4 gigahertz band or even Bluetooth. That would also be a viable setup as well. And so just kind of, it's very vague and open-ended answer, but
So
I think that's the starts of where I would start looking for it.
So in vague and open-ended questions, what kind of house automation have you done for your own house?
Oh, that's a lot of random things. So I have done this setup where I have a Nerves controller and I have little Arduino devices around the house, either taking temperature measurements, or we frequently lose remotes to the televisions. So I have little Arduinos running off the USB power of the TV with an IR transmitter, an infrared transmitter, where I've copied the IR transmissions of my remote so I can just use my phone communicating to my Nerves controller to tell the Arduinos to do what I want them to do. I put in a couple electromagnetic locks on doors that are controlled, that are managed via my Nerves devices. Mainly to keep my kids from making huge messes when we're not around. So it's like locking toy rooms and stuff. It's like a really dictatorship type regime here, I guess, when it comes to children and toys and messes. But it's working, keeping all of our sanity.
Are any of those open source? They sound really interesting.
Yes. Yes, they are all on my GitHub. They probably don't make much sense out of context, but yeah, pretty much any project I'm doing around my house, they're pretty much open source. I've done things to, I've got a sit and standing desk. I've reverse engineered a protocol of my desk so I can monitor the height of it and make it go up and down. That one's basically useless because it's not like it saves me that much time, which is fun. So, and I've built a little ATM machine to manage my children's money electronically, and use a Raspberry Pi and a touch screen and use Scenic and build some stuff out there. But so those are all on my GitHub. I think under my hub directory, I have a hub project and it just has a bunch of different projects that I've created for this, for home automation.
What are some of the things that are not possible to run on Nerves? So is Phoenix, for example, something that could easily, I know it's a bit heavy.
So there, in the Nerves project organization, there's a repo called Nerves_examples. And that lists a lot of things that you can do. And so Phoenix is actually a really common one. And what I actually use with the door locks and stuff, I have a little Phoenix app running from my Nerves device, and then I connect directly to it locally. And so to think about what's not possible, I mean, Phoenix at its core is just a little Linux operating system for an embedded device. So it's kind of just the same question or same answer of maybe whatever you can't do with Linux, you probably won't be able to do with Nerves. And I guess you run into hardware restrictions as well. Just by the nature of embedded devices, you're not usually using real beefy hardware, so you're probably not going to do really beefy processing at that level either. But Bluetooth has been a big one that has not been as easily possible with Nerves, but we've just recently been releasing and doing working on Bluetooth project to be able to use the Bluetooth chipsets on Raspberry Pis to communicate to other Bluetooth devices. It's still in the infancy. The project is called Blue Heron, and it's under the SmartRent repo. So that's very limited in Nerves, but hopefully it starts progressing more and picks up more momentum. So far, all we've gotten is we're controlling Bluetooth light bulbs right now, and that's cool enough. But there's some other thoughts of where to progress with that, do more with maybe beacons and more LE style controls. Oh, I feel like there's something else we always run into, but I'm not thinking of it at the moment, so I'll have to come back to that if I think of anything else that's highly restrictive on Nerves.